Now let's do the same thing for as equal columns. The loop is going to be a bit different though, so let me just get rid of this. Well, so as equal, let's just give it a different name. I shouldn't have copied and pasted, just so it makes sense. I don't want you to kind of have the same idea as the other one. Let's just start afresh, just so you have a fresh understanding of this one, because it's going to be a bit different. So let's define a function. Let's call it as equal column sums. Okay, we're going to go through the list. Okay, so we need our user two-dimensional list. Okay, we're going to check the sum of each column. So in this case, 4, 3, and 8, we're going to get that sum. 9, 5, and 1, get that sum, and compare with our first row sum. 2, 7, 6, get that sum, and compare with our first row sum. So it needs our first row sum. It also needs our number of columns, right? Because we're going to be accessing each element in the list. So I'm going to pass the number of rows, and it's also going to need our number of columns. Okay, number of rows, number of columns. All right. So let's create our for loop. Our for loop here. But this time around, we're going to add them up this way. 4, 3, 8. All right, and then we go back up to 9, 5, 1, and then we go back up to 2, 7, 6. So our loop is going to be a bit different. It's going to be flipped somehow. Right, 4, 3, 8. Right, if you want to refer to them by indices, right, this is row 0, okay, column 0, right? We can even write it here just so it makes sense. That's row 0, column 0, right? And then 3 is row 1, okay, column 0. Column stays the same. And then the next 8 here is going to be row 2, column 0. So the column stays the same. But when we go back up again to check 9, 5, 1, 9 will have row 0, column 1, right? 5 will have row 1. I'm referring to the indices, the index. Row index. So this is row index 0. 9 is row index 0, column 1. Or column index 1. And then 5 is going to be row index 1. Okay, column index 1. Right? And then 1 is going to be row index 2, column index 1. Right? So the column stays the same each time. But then the row is what changes. The row index is what changes. 0, 1, 2, 0, 1, 2. Row index is what's changing in time. So we need to put the loop that goes through the rows inside. Okay, so it keeps iterating from 0 all the way to 2, 0 all the way to 2. But then the column, first time it iterates is going to stay at 0. Second time it iterates is going to stay at 1. And then next time it iterates is going to stay at 2. But each time the row is what changes from 0, 1, 2, 0, 1, 2, 0, 1, 2. That's how we access them this way. Okay, so we're going to keep that in mind when creating this loop here. So we're not going to start with our for current column index. We're going to start with our for current row index, correct? Let's see over here. Sorry, we're not going to start with our for current row index here, right? We're going to start with our for current column index and keep our loop that goes to our rows inside of the outer loop. So we'll start with our for current column index. For current column index in range. That's what we're starting with. The range, we know it's going to be the number of columns this time around, number of columns. And then we're going to create our inner loop. So for current row index in range, number of rows. Right? So the first time current column index is going to be 0, right? And then our current row index is going to change from 0, 1, 2. The next time our current column index is going to be 1, and our current row index is going to change from 0, 1, 2. Third time current column index is going to be 2, and our current row index is going to change from 0, 1, 2. And we can use those values to access the elements this way. Okay, 4, 3, 8, we add them up. 9, 5, 1, we add them up. And 2, 7, 6, we add them up. That's how we use them to access them. So this time it's not going to be row sum, it's going to be column sum. So before we start counting, let's set column sum to be equal to 0, right? Before we start counting, it's 0. And this time around, column sum is going to be equal to what's already stored in column sum plus that particular element we are on. So same thing as this. Use a two-dimensional list. Let's refer to our list here. Okay. And then in order to target the rows and columns, we use our. This time it's going to be a bit different. We don't want to. Let's see here. Actually, that's fine. It's same thing, right? Well, current row index is what we use to refer to this. So let's see here. Hold on. So current row index. So the first time it's 0, so row 0, right? Current column index would be 0. That's 4. And then we need to also pass in our current column index. But let's see if it makes sense here. I'll go through it. All right, so the first time current row index will iterate from 0, 1, 2. So first time will be 0. Current column index will be 0. So 0, 0, that's 4. And then the next time it iterates, current column, this inner loop, like current column index will always be 0. So that's also 0. Current row index will be 1. So row index 1, column index 0. So row index 1, column index 0. So that makes sense. That's correct, right? That's correct. The very first time, current column index will be 0, and it will stay at 0 until all this loop is done iterating. So it will stay at 0. But current row index will iterate from 0 to 2. So 0, 0, because current column index always is at 0. 0, 0 is basically this value 4. The next time current row index iterates, it's going to be 1. So row index 1, column index 0. Row index 1, column index 0 is 3. Next time this inner loop iterates, current row index is going to be 2. Current column index will always be 0, like for this iteration, for this first iteration. So it's going to be current row index 2, column index 1. Sorry, column index 0, okay? Because it will always stay at 0 for the first iteration. So current row index 2, current column index 0. Current row index 2, current column index 0. Then the next time the current column index iterates will be 1. So now we're in the second column, and this will also iterate from 0, 1, 2. Okay, so it works. So this is how we access our column sum. How we get the column sum. We access these elements and we add them to column sum. Now, when we are done with a sum, or basically a column, okay, column sum, outside of this inner loop that does that for us, we need to check to see if that sum is not equal to the first row sum, so we can return false. So, all right, so if in this case our column sum, okay, is not equal to our first row sum, if it's not equal to our first row sum, that means that it's not a Lo Shu Magic Square, right? First of all, it's not a Lo Shu Magic Square, and at the same time it doesn't have equal column sums. This function is going to return false. So let's return false here. Oops, what did I do? Let's just type it. All right, so return false. All right, so before we go to the next column and start adding up these sums, again, we have to, right outside of this inner loop that gets the sum for us, after checking, right, if it manages to get past this, then before we go back up, okay, to the outer loop to start getting the sum of the next column, which is 951, we need to reset the column sum to 0, because otherwise it will keep adding the next column numbers to what's already stored in column sum. So we need to set it to 0. So again, if this program, or if it gets past this loop, it finishes iterating through all of it and it doesn't return false, that means that it has equal column sums. And so in that case, outside of this entire loop, right, if the code gets past all of it and it doesn't return false, that means it has equal sums. So let's return true. So this function will return either true or false. Okay, once it returns false, it stops. If it doesn't return false, then it's going to return true. Okay, so now we have that. Okay, so now I want us to create a function. This time around, we're not going to do like a lot of processing with that. It's just going to be a function that's going to say has equal row and column sums. It's going to be a function that says that. But for it to have equal row and column sums, that means it's going to have equal rows and equal columns. We already have those functions, so we don't have to worry too much about that. So, but let's have one function that does that for us. Instead of creating one function that had all this code, I broke it up into two. Now we're going to have one function that checks these two functions. Now you see what I mean. So let's create a function that's going to check to see if that list has equal row and column sums. Okay, so let's call it has equal row and column sums, right? So let's determine if this, let's check what this function needs, right? But before that, we'll figure it out. Before that, so let's just see the logic of this function. This function is going to return true if the two-dimensional list has equal row sums, and at the same time it has equal column sums. Both of them have to be true, right? So if, I'm going to have an if statement, right? So if, let's see here. Now we can call this function if has, by the way, these functions are available to each other, okay? So if has equal row sums. Let's see here. Let's copy it. So if has equal row sums. Before that, we need to make sure that we're passing all these individual items to this function. So if it has equal row sums, it needs our two-dimensional list, right? Which means this function itself needs our two-dimensional list so that this function can have access to the two-dimensional list. So I'm going to give it a name. I'm going to set a parameter here for I'll use a two-dimensional list. If this has equal row sums, needs it, then we also need to refer to it here. Now, has equal row sums also needs our first row sum, which means that our outer loop has equal row and column sums also needs our first row sum. So we specify that as a parameter for the has equal row and column sums so that our has equal row sums can have access to it as well. We'll pass it to that. Our has equal row sums also needs our number of rows, which means our function itself needs the number of rows so that our has equal row sums function can have access to it. I'm going to pass that to the has equal row sums function as well. And then our has equal row sums also needs a number of columns. So I'm going to specify that as a parameter for the has equal row and column sums function so that this has equal rows function can have access to it. Okay, so we need to continue with our function here. So if it has equal row sums, we provided everything it needs, and at the same time, right? So I'll break this in a second. I'm just going to put it on one line and I'll talk about it. I normally talk about it, but I don't know why I didn't talk about it. I'll talk about something here about this line here in a second. So let's continue all on one line and I'll explain that in a second. So if it has equal row sums and at the same time, right, has equal column sums, right, then we return true, otherwise we return false. If it has equal row sums and it has equal column sums, then we know that this function, this two-dimensional list, has equal row and column sums. So our has equal column sums also needs certain things. It needs first our two-dimensional list. We already have passed it to this function here, so it's available. We can pass it to this, right? Okay, so now I know I'm going to be exceeding this line very soon. So let me pause here and talk about, not pause, but let me just talk about this here. So I don't know if you can see this line here. It's a gray line, and it's this is like a guideline for me not to exceed about 79 characters in a line. So it's a Python standard not to exceed about 79 characters in a line, and I like to follow that. So we need to find a way to break this line here into two, okay, without messing up the line. So I'm going to do that. I'm going to break this line here, somewhere around here. And before you break a line in Python, you type in a backslash and hit enter. So we fixed that point. It doesn't mess up the code, it just visually breaks it so you can see it, but the line is still intact. Okay, so this is also exceeding this line. I'm going to break it somewhere around here. Type in a backslash, hit enter. Same for this, I'm going to break it somewhere around here. Type in a backslash, hit enter. Same thing for this as well. Backslash, hit enter. And over here, type in a backslash, hit enter. Okay, so now it brings me to this. Before we continue, I'm just going to break it somewhere around here. Type in a backslash, hit enter. I know I'm going to exceed again, but we'll break it when we get there. All right, so our has equal column sums also needs, apart from our user two-dimensional list, it also needs our first row sum, which we have access to it here. So I'm going to pass it to this function. It also needs our number of rows, which we have here, so I'm going to pass it to it. And it also needs our number of columns, which you have here, so I'm going to pass it to it. Okay, so we're exceeding this line. I'm going to break, well, first of all, we're exceeding this line, So I'm going to break this line somewhere around here. Before I break a line, I type in the backslash, hit enter, and I'm exceeding this one here as well. So before I break it, I'm going to type in the backslash, hit enter, still exceeding. So I'm going to type in, or break it somewhere around here, backslash, hit enter. It doesn't look too nice, but it's okay. All right. So if it has equal row sums and at the same time it has equal column sums, right? I'm going to type out a colon here. Then that means that this two-dimensional list has equal row and column sums. And so in that case, return true. All right. And then else, return false. So if you call has equal row sums, give it a two-dimensional list and all the things it needs, it's going to return true or false, whether this function has equal row and column sums. It does these two things for us, right? But these individual functions are also there for us. We can use it individually to test things, but all we need to do is just call this. All right, now we're not done. We need to also check to see, now we've figured out if this function has equal row sums, if it has equal column sums. Now we need to check to see if it has equal diagonal sums as well, right? But it's in two parts, right? Because we need to check to see if it has a equal diagonal sum from the left, right, which is 4, 5, and 6. At the same time, we need to check to see if it has equal diagonal sums from the right, which is 2, 5, and 8. So let's break that also into two, and then later on we'll create one function to test both. So the first one I want us to create is a function that's going to test to see if this function has equal diagonal sums from the left, right? So let's create a function. I'm going to call it has equal diagonal. Let's call this has. Let's call it has from left. Okay, has from left equal diagonal sums. Has from left equal diagonal sum. Let's call it sum. Okay, so has from left equal diagonal sum has 4, 5, 3. Is it going to be equal to our first row sum? Something like that. So we need to find a way to target these values, right? So let's kind of use the comment, okay, to explain that. So this value here is row index 0, okay, column index 0. So row index 0, column index 0. 5 is row index 1, okay, and then column index 1. And then 6 here is row index 2, okay, and then column index 2, 0, 1, 2. So you realize in order to access the from left diagonal sums here, 4, 5, 6, it's always going to be 0, 0, 1, 1, 2, 2, 3, 3, and so on and so forth, right? We know that we can, the indices are going to be the same, right? Also, if you look at this 0, 1, 2, it's really the length of any row or column. So the length of any row or column is 3, right? The row, the length of how many rows are in this list is 3, right? And how many columns are in it is also 3. And if you create a range with passing in 3, it will give you values from 0 all the way to 2. So 0, 1, 2. So we can use those in the indices to access these elements, 4, 5, and 6. And I'll explain that in a second. So let's first create a loop that's going to go through our list. But since it's going to go through our list, then we need to pass that list to this function. So I'm going to create a parameter. I'm going to call it user two-dimensional list. It needs a list. All right. So I'm going to create a loop, and I'm going to target these numbers. These numbers are our diagonal numbers, okay? So I'm going to create an index for these diagonal numbers. I'm going to call it for current diagonal number index. So for current diagonal number index in range, the range I want to create over here is from 0 all the way to 2. And I can type in, okay, I can provide over here, in order to get the range from 0 to 2, I can provide over here the length of any row or any column, right? If this is a square, right, and it has 3 rows and 3 columns, when I pass in 3 over here, it's going to give me a range from 0 to 2. So I can use the length of any row or column over here. So what I'm going to do is I'm going to create a parameter here. I'm going to call it length of any row, okay, or column. Doesn't matter whether it's the length of a row or it doesn't matter, or length of a row or length of a column, it doesn't matter. So I'm going to pass in a parameter for that, and I'm going to pass in that value. So if the length of the row is 3, then and the length of the column is 3, any of them will work. If it's 3, according to our program, then it's going to create a range from 0 all the way to 2. 0, 1, 2. 3 is not included. So let's say I type in 3 here. It's going to create a range from 0 all the way to 2. So 0, 1, and 2. And what is going to happen is each time this loop iterates, these numbers 0, 1, and 2 are going to be assigned to our current diagonal number index. First time it iterates, it's going to store 0. We can use that number 0, 0 to target this value. Next time it iterates, it's going to store 1. We can use that number 1, 1 to target this value. The next time it's going to iterate, it's going to store 2 here. And we can use that number to access these values. All right. So I'm going to type in over here. I'm going to pass in the length of any row or column. And then let's do that. Let's write a loop that's just going to target these values. All right. So what we want to do is we want to basically get a diagonal sum. But this is going to be our from left diagonal sum, right? So let's create a variable. I'm going to call it from left diagonal sum. So from left diagonal sum, I'm going to set it here is to 0 because before we start, the value is 0. So from left diagonal sum, let's just copy it. So from left diagonal sum is going to be equal to what's already stored in from left diagonal sum, okay, plus the way we target these elements while this loop is iterating, okay. We know current diagonal sum is going to store 0, 1, and 2 as it's iterating. First time it's going to store 0. And we know this value here is 0, 0. So I'm going to refer to the two-dimensional list, okay. So plus that current diagonal number, okay. We refer to that current diagonal number by referring to the list and referring to their indices. And so the first one is going to be the current diagonal number index. If it's 0, we put in 0 here. And then if it's 0, we put in 0 here. So 0, 0, that's like the first element. The next time this will store the number 1, then we have 1, 1 here. Next time that iterates, it's going to store 2, then we have 2, 2. That's how we get these diagonal numbers, 0, 0, 1, 1, 2, 2. And we'll add them all up here. By the time this loop is done, we'll have the sum of the diagonal numbers from the left, 4, 5, and 6 stored here. We'll have it. Well, I'm exceeding this line here, so I'm going to break this into 2. I'm going to type in the backslash somewhere around here and hit enter. Still exceeding, so I'm going to type in the backslash around. We're going to break it somewhere around here. Never done this, but I hope it works. Okay. So by the time this loop is done, outside of this loop, okay, right outside of this loop, let's check, okay, if at any point our from left diagonal sum, this loop iterates only once, so we don't have to reset anything. So if at any point from our from left diagonal sum is not equal to our first row sum, which means we also need to pass our first row sum or define it as a parameter for this function. So I'm going to do that. We need it. First row sum, right? So if from the left diagonal sum is not equal to our first row sum that is passed to this function, then let's return false, right? Else, let's return true. Else means that our from left diagonal sum is equal to our first row sum. So return true. That means it has the diagonal sum here is equal to the first row sum. Then that's the first row sum is what we are using to check everything else to make sure everything else is equal to that 15, that first row sum. So if this value is not equal to first row sum, return false. That means it doesn't have an equal from left diagonal sum, okay, compared to the first row sum. So anyway, we're done with this function. Let's do the same thing for has equal from right diagonal sum. It's going to be kind of similar, but a bit different. So that means we're accessing these numbers here, 2, 5, and 8. The indices are going to be a bit different. So let's talk about that. But before that, let's create that function. So let's define has from right equal Over here we call this what has from left equal diagonal sum. Let's make this a bit more descriptive. Let's call it has equal, okay, has equal from left diagonal sum. And over here let's call it has equal from right diagonal sum. I think it's just a bit more descriptive. Okay, so has equal from right diagonal sum and has equal from left diagonal sum. Okay. So we know it's going to be going through a list. So let's pass it, or let's define it as a parameter rather. It's also going to, is it going to need a length of an row or column? Since we're well, before that, we'll figure that out, right? Let's just check, okay, the indices of these numbers, right? So let's use a comment here. To access 2 is going to be row index 0, column index 2, right? So row index 0, column index 2. And then we have row index 1, okay? To access 5 here, it's row index 1, okay, column index 1. Row index 1, column index 1. And to access 8, it's row index, okay, 2, okay, column index 1. Row index 2, column index, sorry, row index, hold on. Row index 2, column index 0, okay, column index 0 is for 8. Okay, row index 2, column index 0. And so you can see that, okay, for these numbers 0, 1, and 2, we don't have a problem. You can use our length of any row or column to get those indices 0, 1, and 2. But we also have to figure out a way to get these indices 2, 1, and 0. So we can use these indices to access these elements 2, 5, and 8. All right, so we know 0, 1, and 2. We can use our length of any row or column to get them. So let's pass that also, or let's define that as a parameter to be passed to this function, so we can get at least the indices of the rows. And then we know we are going to need our first row sum, so we pass that also because we need to compare the sum, okay, of the from right diagonal sum to our first row sum. But we need to figure out a way to get these this 2, 1, and 0. So let's start with our loop. So I'm going to create a loop, okay, that's going to go through this list here, this two-dimensional list here. It's still going to be a current diagonal number index, right? Because this is a diagonal number index. Oh, sorry, these are diagonal numbers, so we're going to create a diagonal number index to refer to them. So for current diagonal number index in range, well, for the rows is we're going to loop 3 times, and while we are looping, they're going to have index from 0, 1, 2. So we can use this number here for length of any row column to specify how many times it should loop. We know it's going to loop 3 times. So if it's 3, then it's going to loop 3 times. But then the numbers 0, 1, and 2 are going to be assigned to current diagonal number index. But let's see here. Let's see. So this here, let's not call it current diagonal number index, right? Over here we could have, right? We could because really these represented the indices of these numbers. But over here, this number here is going to represent 0, 1, 2. So and these indices are actually the row indexes. So current diagonal number row index. All right. This is just going to represent 0, 1, 2, the row index. We can't use the same number for these indices 2, 1, 1, 0. So what I'm going to do here is, in order to get 2, 1, 0, we know the length of any row column is going to be 3, right? What I'm going to do is I'm going to create a variable for our current diagonal number column index. Let's not call it row, let's call it column index. In order to get that, it first needs to start from 2. So let's initialize that. It's going to be equal to the length of any row column. We know it's 3, okay, minus 1, right? So our current diagonal number row index, we know when we pass in the length of any row column, this is 3, it's going to create a range from 0 to 2. And the numbers 0, 1, and 2 are going to be assigned to this current diagonal number index. This current diagonal number row index. Really, these numbers are the indices for our rows, 0, 1, and 2. So we're all set with that. In order to get the current diagonal number column index, we need the numbers 2, 1, 0. right? The very first time we can get it by subtracting 1 from the length of any row or column, and that is 2. So it starts off as being 2. So we can use those numbers at least to get the first number here, which has row 0, column 2. We know this is 2. We know our current diagonal number row index is also going to be 0. So we need a sum as well, right? We need a variable to get the sum. So this is going to be our from right diagonal sum equal to 0. From right diagonal sum is equal to 0. And then our from right diagonal sum is going to be equal to what's already stored in our from right diagonal sum, okay, plus that current diagonal number. And in order to target it, we use your indices. So we target the list, we specify the row index and the column index. So the row index is going to be our current diagonal number row index. And then our column index is going to be our current diagonal number column index. Right? First time out, current diagonal number row index is going to be 0. Second, and the first time out, okay, the current diagonal column index is going to be equal to 2, right? Because it's 3, that's the length of any row or column, minus 1, which is 2. And 0, 2 we can use to access the first, this number here, which is 2. We can use that. But the next time, let's see what happens. When it iterates again, current diagonal number row index is going to be equal to 1, right? It's iterating from 0, 1, 2, right? Basically, the numbers 0, 1, 2 are going to be assigned to this. So the next time it's going to be 1, right? And then what we need to do, because current diagonal number column index is still going to be 2, we need to also figure out a way to subtract 1 for it so we can get 1 also for the next element. And so after doing this, we take our current diagonal number index and we subtract 1 from it. So current diagonal number over here, we take our current diagonal number column index and we subtract 1 from it. So our current diagonal number column index is going to be equal to what's already stored in our current diagonal number column index, minus 1. Okay, so it starts off as 2. We use 2, okay, to access the element in our list here. We know our current diagonal number row index is going to be 0. So 0, 2, that's the first element. And then we subtract 1 from it. So current diagonal number column index is going to be now 1. Okay, now 1. The next time this loop iterates, current diagonal number row index is going to be 1 as well. So 1, and then current diagonal number column index is 1. So 1, 1, we access this element here. And then we subtract 1 from our current diagonal number column index. So this will be 1 minus 1 gives you 0. So we have 0 now for our current diagonal number column index. The next time this loop iterates, current diagonal number row index is going to be 2. Okay, we have the row index, which is 2. And because our current diagonal number column index is 0, that's going to be 0 as well. So 2, 0, we access this this element here. Right, 2, 0, row index 2, column index 0. And then we take our current diagonal number column index, subtract 1 from it. So even though it's 0, we subtract 1, we're going to get negative 1. But it doesn't matter because this loop doesn't iterate again. This current diagonal number row index was assigned a number 0, 1, and 2. That's it. It iterates 3 times and that's it. So it doesn't matter if this goes to negative 1 because it wouldn't iterate again for this number to be used here. So it works perfectly if we do it this way. All right. So by the time this loop is done iterating, we will have our from right diagonal sum. And then after outside of this loop, we check to see if our from right diagonal sum, okay, is not equal to our first row sum. Okay, similar to what we did over here. Then we return false. Then else we return true. Else means that our from right diagonal sum is equal to our first row sum. Okay, return false if our from right diagonal sum is not equal to our first row sum.